First we go from ground to the upper stratosphere, to a station that is sitting in the upper stratosphere. There we have a bigger airship that takes us into orbit. I'm going to show you some more about that. This one is slowly accelerated in the upper stratosphere by electric propulsion until it reaches orbital velocity. It's like a gigantic supersonic wing. Okay. Okay, let's go back to this one. Okay, I showed you the entire thing, and after that there were plenty of pictures to show how many missions already have been flown by JP Aerospace, and I will show a few of them later. Anyways, the first thing is we want to go from the ground to that big dark sky station that is sitting in the upper stratosphere. For that we have this V-shaped airship that is optimized to fly to the upper stratosphere fairly quickly. It's like an elevator. And the dark sky station is that outpost in the stratosphere, and there, this is needed to construct the orbital airship. The orbital airship is about 1.5 kilometers long. It's really huge. But it's an inflatable wing, like a supersonic wing, and it has static and dynamic lift. So in the beginning, when it's standing there, it's inflated with hydrogen, and then you have a propulsion system, some electric propulsion system that slowly pushes it onto speed. And the faster you get, the more dynamic lift you get, so you go higher. And and the higher you go, the less drag you get, so the faster you go, and at a point you reach orbital velocity, and you're up there. And the idea is so crazy, it could actually work. That is not my statement. That is a statement of a famous science fiction writer. I just forgot his name. I'm really sorry about that. But anyways, here I show you the ascender. We already built like 5 different versions of that thing. A little one to test, structural things, and we got this one, and we thought that is big. And then we built this one. And here you can see a human. So you can get a picture on how big that is. Here's a ladder for references. That thing is about like 5 meters high. That is about like nearly 30. What? Oh, it's a thin fabric that's used for parachutes and balloons. What fabric that is? It's a thin material that's used for parachutes. It's a very thin PVC material, I guess. I'm not quite sure what it is, but it's like a thin fabric that's used for balloons. And the one that's going into orbit looks like this. So it's even bigger, and you have the propulsion here in the center. And that is the model you saw in the movie. So that is the final orbit. That's the final version that is built for manned flight. I'm not quite sure how large that is. But there's plenty of information on the webpage of JPA. Anyways, the next thing is the dark sky station. You saw already the pictures of those little balloon-based ones. The next one will be fully contained, the upper left one, with like tall balloons that are wrapped. And then this is the first manned version with a little capsule in the center. And the lower one is the big one that spans across like about like 2 miles, which looks very much like this here. So you have a structure in the center, and you have those arms that keeps the structure in position. So to tell, and the third part of that thing is the orbital spaceship or the orbital airship, and to test that, currently they're building so-called Mach gliders, which are small models of that airship. And here you can actually see how the building happens at JPA. You've got your big shop, and they are folding together a Mylar mock-up of one of those Mach gliders to test the deployment of that Mach glider out of a rocket. The idea is to use a rocket like in the Raccoon we use for the Cat's Prize. They want to launch a rocket from a balloon or from a balloon-based structure. So you get an altitude of like 300,000 feet. You really reach space. And from there, you deploy the wing, and you can now let it fall down to actually achieve high velocities and test the wing in different Mach numbers and in different speeds and different Reynolds numbers, if that says anything to you about this. The Reynolds number is a factor for the flow around how turbulent the flow is. And you can see how that thing is being deployed, like it's in one of those tubular structures, and it's just being inflated by a cartridge. And then you can get a picture on how big that structure actually is. and it's actually being launched, and it's out of Mylar, so it's fairly small, but like when it's inflated, it's fairly big. So you can do like tests of this kind of things in a space environment. This is the next step to go towards the orbital spaceship. And talking about rockets, I want to show you that one. That is the launch of the microsat launcher, which is a system to deploy that Mach glider. This is just a test flight for the deployment system that will be used for the Mach glider. So I'm going to show you a bunch of flying objects we used at JP Aerospace. This is at 100,000 feet, and it's all not to scale. You see that balloon structure, the little dark sky station that is used to launch the rocket, and there's above it you can see the rocket that is being launched up to 200,000 feet or so. And this is the domain of the little ascender airships. And this you can see the different ideas of dark sky stations, and I don't know what that one is here. That looks like a UFO to me, but I guess that is one of the airships JP is working on. And up there, that's where we want to go. That is space at 1,000,000 feet. That is like out there, and there you can see the 3 suggestions for prototypes for actually orbital airships. So general idea is really, we don't launch on the ground, but we launch from up there already. Then we accelerate and get out into space. So how do you do it? I was talking about hacking space. Like, what do we have to do different than the big business where you say, I want this and this, and get it. I don't care how much it costs. So the idea is build a little, fly a little. So we build a lot of little objects that we fly to find out properties, to test technology. We actually be flying a lot. Like every year, JP is flying about 5 to 6 missions. Depends on the year. There were years with less missions and years with more missions. Then you reuse hardware, like everything that comes back down, you use again or modify it. And you use high tech, but off the shelf. I'm not talking about off the shelf that you have in your drawer and you just take out, but off the extreme of the shelf, like off the shelves of Walmart, or off the shelves of Radio Shack, off the shelves of Germany, Konrad Electronic. So we are talking about really stuff that is everyday stuff, but high tech. And the thing is, because it is everyday stuff, or it's off the shelf, it's mass produced, so it's cheap. If you want to have your one single thing that is only produced for your mission, it's going to be extremely expensive. And the other idea is you got volunteers. JP Aerospace is a volunteer organization. Volunteers are cheap, they're for free. So you can build a lot with people that are just having fun doing so, instead of people that are being paid to do so. And of course, use a lot of quick ties. That keeps everything together. Like, quick ties are Kabelbinder in German. So you all know that stuff. I mean, all the airships, all the missions I've shown you so far were held together by quick ties. Very little a few screws, a little bit of epoxy, but mainly quick ties. And they're amazing what you can do with quick ties. I've never thought you can do so much stuff with quick ties. Hey, let's talk about our technology. We're using amateur radio for communication. We're using basic stamps, PECs, like little processors for the onboard computers. We use foam core, which is this stuff here. In German, it's called Architekturpappe or Schaumpappe. It's like paper with foam in between. And it's highly insulative. It's very light, very rugged actually. That's the good stuff. And we use carbon fiber wherever it's possible to make things as light as possible. But carbon fiber is sort of expensive. One major source for carbon fiber are arrows. Like with arrows, you get carbon fiber tubes about that long. They are really good. They are very strong, fairly cheap. And what we do is we just put aluminum caps on the top of those, and the aluminum caps are pushed together, hole drilled, and they are epoxied onto the arrows. And with that, you can build huge structures. I mean, like the structures for the 2 big Ascender airships were all made of those tubes. And they were just on the top of it, there were bigger tubes that kind of kept it together, and those are kayak paddles. They're about tubes that big, and basically those are kayak paddles, and when and you get them quite long, and you use that for tubes. And if you don't have any tube or stuff that is not fitting, you have to do it yourself. Like, you can do amazing carbon fiber structures with carbon fiber pads, epoxy, and then you vacuum it using one of those vacuum things, vacuum pumps you use for freezing food. You know those things you can buy where you have this big spool with the bags, and you have this vacuum pump in there, and you can put your steaks in there or your chicken, and you suck the air out and freeze it. You can do amazing carbon fiber objects with that method. It's a bit tricky. You have to put in a tube. Anyways, did I tell you about the quick ties? We use so much QuickTies, like it's amazing what you can do with QuickTies. And of course you use everything else that's useful. Like you used PVC piping from Home Depot for the antenna stands. We used everything that you can get, you know, in Walmart. Walmart has had a good price on lithium batteries, like, and of course you use QuickTies. So the other thing that will happen is one of the things JP does, like to kind of nudge NASA a bit on the side, is some educational thing. With every mission, you have excess lift. Like you can put on a kilogram more to fly stuff. So JP thought of a thing called PongSats, and it's an experiment that is put into a ping pong ball to limit, you know, the size, and the weight is limited to, I guess, 3 ounces. Like it should be fairly light, and it doesn't cost you anything to fly it. Like if you want to fly such an experiment, write an email to John Powell, say hello for me, and send him the ping pong ball with your experiment. And it's going to be flown to the edge of space and you will get it back. And this is, you know, made to excite high school kids for space flight. Like, I mean, NASA does that, but there are alternatives to NASA. And of course, it's a challenge, you know, to put an experiment into a ping pong ball. I mean, those are really fancy things, as you can see. So I'm going to talk about Weight 25 now. That is a mission where I highly participated. Whoops. I'm going to show you a little video again. No sound this time. And this is about a Weight 25. That is a mission where I built a big deal of the onboard electronics. I used a network, an RS-485 network, to connect those basic stems together. And we had a microcontroller on board. Here you can see there were video cameras on board, those PongSats. This is a helium pump for the airship, and that is the electronics box for the airship and the digital camera down there. I will show that in close-up later. There's a parachute on the upper left, again the helium pump, and we got sponsor logos on the sides. I mean, all this is financed by sponsor money. There's no financing from any other sources but sponsors. But for the big ascender, the sponsor is actually the US Air Force, and JP probably doesn't want to get into any deals with those guys anymore. Here you can see the launch. The balloons are released, and those guys are doing a little dance and release the package. You can see how the balloons go into the right position. And at this flight, we were actually flying polyethylene balloons. Those are fairly expensive and hard to get. On most other missions, we were flying rubber balloons, like the ones I'm going to fly on Friday. And here you can actually see the onboard camera after launch. This happened in Black Rock Desert, which is about 300 kilometers northeast of Reno in Nevada. It's a big old lake, like a salt lake. And this is actually the place where Burning Man happens every year, and where the last speed records for cars have been achieved. Here you can see the lake very nicely, and you can see how we get up there. And one thing that happened during that flight, there was a digital camera on board, snapping away, taking digital pictures. And this is the video, and the video only lasted until up, not down anymore. But you can already see as space coming up, the darkness of space. You can see the curvature of the Earth. And we want to get up there. But we're already pretty close. I mean, that flight went up to 96,000 feet, which is about 32 kilometers. But here you can see that's how it looks when you're really out there. Like now you can really see the curvature, and you can really see how thin the atmosphere is. You can see reflections of the ground. just love those cloud pictures. I'm going to show some in a few. At this mission, I was actually mission control. I was in charge of starting up the electronics, giving the okay for launch, and like getting the GPS data, giving the commands to the controller. And actually, what happened during that mission is we had those 3 balloons, and at altitude, like at 96,000 feet, one of the balloons popped, so it came down on 2 balloons at about the same speed as it took up, which was really neat. So we got a lot of pictures from out there, and very close to landing, like in 10,000 feet altitude, I gave the command to cut the balloons, and it landed right where we wanted it to land, very close to a road, like we were tracking it on the map. And at that point, we decided, hey, we cut down, so it comes down at the road, so we can pick it up. Because that desert out there, there's nothing. There's no cell phone reception. There's nothing. The only way to communicate is 2-meter amateur radio or Global Star. And we didn't have Global Star. So, yeah, that is the Way 25 video. And I'm going to show some pictures. Up there is the team. JP is the one to the right in the shade. And there's another few pictures of the package. And here you can see the Pong sets down there. And this little box here is the digital camera. This is the controller for the helium pump. And behind there, this box is the battery. And below that was the controller for the reception and the parsing of the commands. Anyways, that is the big result of that flight, which is a panoramic picture from that altitude. And the thing is, I got something really amazing here. This is a printout of that picture at highest quality on an HP printer. And after my talk, I'm going to auction that off. Like, if it's 1.7 meters times 3 meters. It's like, if you put that into a room, it's like, wow. And this is the 3rd copy of that poster. There's one in John Powell's office. When you sit at this desk, he sees it. There's one in my office, and this one. And we're going to start at 50 euros, but later. So some odds and ends. I managed to get into the February edition of Penthouse of 2003. What happened is, as an initiation rite at JP Aerospace, you can put on a precious suit from a Russian MiG-29, which is made here in this beautiful country, in the former DDR. And I was wearing that thing. I said, hey, that's awesome. I can drive my convertible around in the winter. Outside it was fairly cold, so I sat into the convertible, opened it up, put those tubes onto the heater, and drove to the next Wendy's to get some French fries. The girl behind the counter got a hysterical laughter, but I got my French fries and I got back. And I told that story to a guy from Penthouse, and he actually wrote it, including my name, into the Penthouse. So this is another one where, can you see that big rocket behind me? That is an attempt from a Texan guy to fly a rocket into space, and this flight didn't happen. They tried it again 3 months after, and it blew after 3 seconds, like it went kaboom. Amazing. This is actually the same rocket they flew the ashes of Scotty with. After like 3 flights or so, they finally managed to get that thing not go kaboom after 3 seconds. Texans, they have money. That is actually a band called Space Vacuum, which is having a party at the JP Aerospace spot. And those guys are having way too much fun, like putting a disco ball into the mission van. Anyways, what's going to happen on Friday or Saturday at 10 is I'm going to fly a thing called Weg 1. Because in Germany, you know, I can't call that away, which is this little thing here. I'm going to open this up. It contains, if you can see that, It's a digital camera. It's an RPRS transmitter. It's a microcontroller and a GPS and a cell phone. And we're going to fly that into the stratosphere using a balloon right here on site, Friday or Saturday at 10, depends on the weather. And I actually have a permission to fly that, which is fairly cool, I think. And you can all watch, and I might even need some participation. Like we're gonna send out, like if you're an amateur radio fan and want to go out and find it, we might need people for the recovery team. But everybody who wants to participate just comes to me after my talk. And yes, if we might even fly a Pong set on that mission, and if you manage to get a Pong set together until Friday, and it's not too heavy, it might be just duct taped to the top of that thing. We're going to fly it, okay? So that's a challenge for you. And yeah, are there any questions? Which one? Oh, what was the weight of a weight 25? I do. You want to know the weight of a weight 25? To be honest, I can't remember. It was something in the order of 30 pounds, I remember, but I'm not sure. You can get all the information from the web page. I was mainly doing electronics at JP Aerospace, not too much aerodynamics or flight. Any other questions? Yeah. You need a microphone, I guess. Oh, he just asked one. Yeah, I'm gonna front to back. Sorry, guess that's the easiest.
What about fragments in space? Do they do these things account for that? Like, say, multiple chambers if one gets.
Yes, there might be an issue about that. Probably you have to enforce the tip of that thing, or you have to kind of fly at the right spot to not hit any fragments into space. Yes, that's most certainly a big issue. But that thing is reusable. Like when it's in orbit, it will come back and dock again with the dark sky station. So it's not like space trash. It's going to be a reusable spaceship because you can slow down. Okay.
How do you keep the dark station in the sky? Because you have to be at orbit to not fall down. You have to put energy into it.
Oh, you got the ascenders going up and down, like you get supplies. So the idea is to refill the hydrogen or helium.
How long does it usually take to get up to orbital height?
Oh, that's actually a good question. Sorry, I didn't tell you that. The idea is that the process to accelerate into orbital velocity is going to take about a week to 10 days. Like it takes fairly long.
But how long does it take to get up to 100,000?
Oh, from the ground to, you want to know how long it takes from the ground to the upper stratosphere?
Yeah, like the balloon.
The one I'm going to fly on Friday? About 1.5 hours.
1.5 hours.
Yeah, you got a climb rate of about 1,500 feet per second. Per minute, sorry.
What is the advantage of starting the rocket from the stratosphere, not from the ground?
I don't understand you.
Like it's a two-stage process, as I understand it. Like first you launch a balloon to the station, and from there you launch a rocket. Not as a rocket, but ion drive.
The ion drive. Yeah, one of the things that is a bit of. Do you want to know what the propulsion is to take the big airship into orbit?
No, what are the advantages of launching from the stratosphere further
Yes.
to the ground?
Oh, from the ground to there, you just use propellers and motors, electric motors. Why do you want to launch from the, yeah. The big airship that goes into orbit is so, the big airship that you launch into orbit is so big, like size-wise, it's like 1.5 kilometers long. And to assemble it, you need the station. You cannot assemble it on the ground. It's just way too large to be assembled on the ground. That's why you assemble it up in the stratosphere. Like the idea would be to basically build modules being carried aloft by the ascenders and put the modules together.
It's then automatically on the stratosphere, or how is it assembled on the stratosphere?
I don't get you acoustically.
How is it assembled?
How it is assembled? By people living up there. There are people living there, and you can use those ascender ships. They are built that you can maneuver in that altitude with the propellers. So you put it together. People wearing like pressure suits, and you of course can propel. You have to move the parts probably by if you attach something. That is engineering that needs to be figured out, indeed.
Does electric propulsion mean normal mechanical propulsion powered by electric power, or is it some kind of ion drive strangeness?
One of the ideas is that you use the filling of the balloon, like the hydrogen, and push it through an ion drive. And you got plenty of space to collect solar power, or you use all those detail issues are being highly discussed and worked on. But it's definitively feasible. Especially the propulsion issue is a little bit of a trade secret of JP Aerospace, because there are other companies like Lockheed Martin, working on similar projects. So I can't talk much about the propulsion system.
Any more questions?
Yeah, okay, this is maybe showing my complete ignorance about some of the stuff, but you're talking about lighter than air methods. How far up do you get before lighter than air is just not something you can really combat with, because you have to then be lighter than the surrounding atmosphere, which I imagine is extremely low.
Well, the dark sky station is going to be at 120,000 feet. And you have, and then you basically have that, you have the orbital airship that is lighter than air when you launch it. And then I don't know when the dynamic lift exchanges the static lift completely. As I said, I was more doing the electronics, but they run simulations on that. It is feasible.
How high can you get with the helium balloon? How high? Which altitude?
How high can I get with a helium balloon?
Yes.
Oh, the current record is like 200,000 feet, somewhere around that order. Not much higher, because it goes quadratic.
How much kilometers is this?
That depends on the size of the object you fly. It's like 1 cubic meter displaces. Oh God, I don't have the number in my head at the moment, but I can get you the numbers later. Okay, so any more questions? I got this awesome poster here, and it is a beauty. Like, as I said, it's 1.7 meters times 3 meters, and I will start off at 50 euros. Anybody who brings 50 euros can have it. Anybody offering 50 euros? 50? 60? Anybody offering 60? 60? I got 60. Anybody offering 70? 70 euros for this beautiful poster? 70? 70 euros. Anybody offering 80? I mean, printing that out in a shop is like 200. Just to give you a figure. Anybody offering 80? 80 euros? Anybody offering 90? Come on, dudes. 90 euros? It's really beautiful. I mean, I showed you the picture on the screen, like, that's how your wall will look like. It's like a wallpaper. Anybody offering 90? Okay, 80 euros, it's yours. Come on to the front, get it? Thank you very much. Who is the sponsor? Okay. Okay, it's a deal. I'm at the Chaos Valley, so you can pick it up there. Okay. Thanks again.